And to factor this is a little difficult. 4z squared minus 12z plus 9. You can factor using a formula, or you can use my diamond method that I teach in other courses. This is where you take the a times the c, and then you take the b, and you're going to search for two numbers to go in these squares that multiply together and give you the a times c value, that add together and give you the b value. This is what I call my diamond method of factoring third degree polynomials. Okay, so in this particular case, where we see that we're going to factor 4z squared minus 12z plus 9, it's all on the left side, that is az squared plus b times z plus c is greater than 0. So you have to make that comparison to determine what is a, what is b, and what is c. So now we know a is 4 and c is 9, so 4 times 9 goes up here. And then b is negative 12, that goes down here. So we're looking for two values to put in the box. And these values have to multiply together to give me 4 times 9, which is 36. And they need to add together to give me negative 12. I think for a moment, and I say, yeah, that's negative 6 and negative 6. So what do you do with that? Well, that implies that our 4z squared minus 12z plus 9 greater than 0 can be factored by removing the middle part, negative 12z, and replacing it with the sum of the two values in the box. So we get 4z squared minus 6z minus another 6z, and then plus 9 greater than 0. Now we're going to factor by grouping. Out of the first group, the first two terms, we have a common factor of 2z times, it leaves 2z minus 3. Out of the second two terms, we have a common factor of negative 3 times 2z minus 3, bring down greater than 0. So we have a miracle factor that comes out in the front. We have 2z minus 3 times what remains. When we strip away the first factor, it leaves 2 times z. Strip away the second big factor, it leaves negative 3. Bring down greater than, bring down 0. Okay, so we have factored, got everything on the left side and factored it. Now we're ready for step 2. Step 2, by the way, this is the sign graph method. The sign graph method for solving a second degree inequality in one variable. The second step is replace the inequality sign with the equal sign and solve for x. Replace this sign with this sign and solve. Okay, so that means we have 2z minus 3 times 2z minus 3 is equal to 0. Okay, so we're going to solve this by setting each of our factors equal to 0. Here we get 2z minus 3 equals 0. Union that together with this factor equal to 0. Wow, they're exactly the same, so we're going to get the same solution when we solve these. This was 3, and then z is positive 3/2, and we get the same thing here. All right, we're ready for step 3. For step 3, we're going to use these numbers to partition a number line. Okay, so partition a number line using, well, we only found one number, z equals 3/2, even though it looks like we have 2, it's just 1. Okay, so we're going to make some space on the left and draw this number line. And the only number of interest on this number line for us is 3 over 2. And over here on the left side, we're going to write each factor in step 1. I'll make a little star here. This is what I'm referring back to whenever I say step 1. The star. Okay, so that's the factor 2z minus 3 times 2z minus 3. We're going to see what the sign is for each of those factors and each of the regions that we have on the number line after we use the number from step 2 that we found to partition the number line. So this is step 4. Step 4 says in each region find the signs of the factors and the product of the factors from step 1. So this is about find signs. Okay, and then the factor will go, let's see, choose a value. This is an x-axis. Choose a value for x to the left of 3/2. Let's say 0. 0 lives to the left of 3/2. 2 times 0 is 0. Minus 3 is negative. So that will be negative. Times the second factor. 2 times 0 is 0. Minus 3 is negative. And then when we multiply negative times negative together, we get a positive. Now, for values greater than 3/2 on the other side of the dotted line, we choose a value, say x equals 100. That lives on the other side. So 2 times 100 is huge. Minus 3 is still positive. Times 2 times 100, that's 200. It's huge. Minus 3 is still positive. A positive times a positive together gives me a positive. So it looks like in both of the regions, we end up getting a positive result when we multiply our factors together, when we choose values from that region. Okay, so now we're ready for step 5. Step 5 says, shade the regions that makes the inequality in step 1 true. Shade regions satisfying step 1. So we look back at that star, and we need it to satisfy 2z minus 3 times 2z minus 3 is greater than 0. Now, what does it mean to be greater than? To be greater than 0, it means positive. So we're going to just shade regions of the number line that make the product of the two factors positive. Well, you can see from the starburst in step 4, that means all the region to the right of 3/2 is going to be shaded with an arrow. All the regions to the left of 3/2 will be shaded with an arrow. So it looks like everything's shaded, but the fact is that we haven't really discussed what happens exactly at 3/2. So let's go to step 6 where we take care of that. And that says if you have a greater than or a greater than symbol, that implies that we exclude the 3/2. And if we have, which is the endpoint, if we have the less than symbol, this is greater than, if we have the, no, that, what I want to say is if we have greater than or less than, we exclude the 3/2 endpoint. Compare that to if we have less than or equal to or greater than or equal to. That implies that we include the endpoint. In this case, we look back at the original question, and it had no equal portion in it. We had greater than with no equal portion, so that implies excluded. We're not going to include the endpoint. So we go back over here, and we can make a round empty circle to indicate that we're not including it. So the last thing we're going to do is write answer in interval form and the graph form. For graph form, we'll have our number line, we have our 3/2, and instead of putting a circle, a round empty circle, I'm going to put an open bracket here, like the book likes. It likes open brackets, and shade everything on the left side with an arrow. And then I'm going to buttress right over here another open bracket with and shading in an arrow. So you see, this indicates the same that the open circle indicates. We're not including the value 3/2. That's my graph form. And then my interval form, I express the first interval, smallest value shaded negative infinity, largest value 3/2. Open at negative infinity, open at 3/2, union together with positive 3/2 is the smallest value shaded in the second interval, infinity is the largest, open interval at 3/2, open interval at infinity. And those are my solutions.